Okay, now I want to talk about Python's equivalent of arrays, which they call lists. And I think you'll see they're much easier to deal with than arrays in Java or C++. So let's just get right to it. All right, let me go ahead and interact with Python, create a list, which looks like this. I guess I'll say 1, 7, 3, 3, 9, 1. Okay, fine. And actually, you may have noticed already, but you don't need semicolons in Python. If you have them, it's not a problem, but you don't actually need them. Okay, so this is a collection of elements in a specified order. And you'll see it pops up in the Variable Explorer here as well. Just as you would in Java or C++, you can access these elements according to indices, which are 0 indexed. So I say x at index 0, so in the brackets there, that gives me a 1. If I say x at index 4, that gives me the 9. So I say 0, 1, 2, 3, 4. Okay, so these are 0 indexed. X at index 5, that gives me the last element there, which is a 1. If I try to say x at index 6, it's going to tell me it's out of range. So like Java, it actually throws exceptions. So that's good, unlike C++, where you could just keep going until you crashed into your program. Totally ate itself. Okay. All right, so that's sort of the same so far. Now, to figure out the length of a list, you say len. Okay, so this one we see is 6. So if I wanted to access the last element without knowing how long it was up front, I could say x at index len x minus 1. And that would get me that last element there. But there's actually a shorthand for this in Python, which is quite nice. If instead of writing this, I write x negative 1, I mean, major alarm bells would be going off your head if you were in Java or C++, because that should be to the left of where I start. That should be out of bounds. But in Python, it actually means this. So just to show you another example, if I say x len x minus 2, well, that should give me the second to last element. The same thing, if I write x negative 2, that gives me that second to last element. So when you say negative, it's coming in from the end, from the right there. So negative 1 is the last element, negative 2 is the second to last, negative 3 is third to last, and so on. So that can be pretty convenient, actually. But you should watch out also, because you may accidentally be going from the end. So if you have negative indices, that's actually what that means in Python. Just to show you one of the pitfalls with types, let's say I defined an index I that was 10, and then I said I is equal to I divided by 2. Remember the shorthand here, I divided equal 2. So that's going to be a float. So if I try to say x at index I, it's going to yell at me. Okay. So this is where you have to be careful with your types. So if I'm trying to use this as an index, it needs to be an int. So I should really be saying this is how you do casting in Python. Okay, so I made I 10, I over 2 is 5. 5 happens to be the last index in this array, which is 1. So just be aware of that. If you end up trying to, when it says, if it ever gives you this error, list indices must be integers or slices, not float, that's a hint that, oh crap, I must have, even if it's a whole number, it must have been the wrong type. So overall, types are way easier in Python. You usually don't have to worry about them. I didn't have to declare my variables as having a certain type, but they automatically get cast behind the scenes, and sometimes that can be a pitfall. Okay, cool. So another thing I want to point out about lists is that they can have heterogeneous elements. So they can have elements of mixed types. So I could make a list like this. So 3, 7, 1, Chris, true, 9.5, 4, 7, 2. Okay, so this is fine. This Python didn't crash or anything. I could never do anything like this in Java or C++. The arrays all had to have the same type, right? But here they can be mixed. So I can say x at index 3 here is that string. X at index 4 is a Boolean. So let's just check. And I didn't mention this last time, but there's another primitive type called a bool. Okay. And then x second to last element is the 7 there. And you can even, so you can always update elements in an array too. Let's say, hey, you know what? I changed my mind. Let's make the element at index 5 instead of 9.5. Let's make that itself be a list. So now notice that okay, actually an element in a list can itself be a list. So if I say x at index 5, I get back a list. And if I say x at index 5 at index 2, I get a 3. Okay, so first I pull out the list that's in the list. Then I go to the last element, which is at index 2 there. So anyway, the point is lists are incredibly flexible in Python. And they don't always have to be a fixed length either. I can say, if I say x.append, some new element. So I'll make a string. Notice that it just went ahead and added an element at the end there. Very nice. Remember, if we were doing this in Java or C++ and we wanted to add elements, we had to make an entire new array and copy everything over. So that really was quite tedious. So lists in Python are really much more like array lists in Java or vectors in C++, if you're aware of that, because they can grow. Okay, so that's nice. Now, another thing that's really cool about lists is that you could do something called a slice. So you can actually make new lists that are just parts of this list very easily without using loops. So for example, if I say the following, x0:3, let's see what that gives me. So that gives me just 371. So what it's saying is start at 0 and go up to, but not including 3. So 3 is one beyond the last index that I'm going to include in this slice of the list. I'm slicing stuff out of it. So then, if I said x1:5, for example, that would give me, it would start at index 1, go index 2, 3, 4, and then 5 is one past the end. Okay, so that's how slicing works. So notice again how much simpler that is than writing a loop. If I want to just take out part of a list, that's all I have to do. Now, you can get even fancier than this because you can also say something like x1: well, okay, actually, if you say 1::, that will take everything up to the end. If instead I say 1:5:2, let's look at the difference here. Well, see, that'll take every other element. So it's saying start at index 1, go as far as you can up to but not including 5, but actually hop by 2 each time. So let's check. So I started index 1, 7. I hopped by 2. That's index 3. Then I tried to hop by 2, but I was actually beyond the end of what I was asking for here. So if instead I say 1:8, 1:8:2, then I'm going to get, okay, 7, skip, Chris, skip, 1, 2, 3, skip, 7, and then I'm done. Okay. And so what it turns out, yeah, so if you don't have this second colon here, it's assuming that you're always going contiguous, that you're going one at a time. So it's assumed to be 1. But you can also do the following. If you leave out the ending element, it'll actually assume the ending element is the end. So here's another thing. So this will go by 2's until it gets to the end. So let's check. So starting at index 1. So 7, Chris, 1, 2, 3, 7, new element. Cool. Let's go by 3's until I get to the end. So 7, skip, skip, true, skip, skip, 7, skip, skip. Whoops, I ran out. Okay. Now it turns out you can actually jump back as well. So this doesn't have to be a positive number. This can actually be a negative number. So if I said, let's start at index 6 and go backwards by 1 as far as we can. Okay, so here's index 6, and then we keep going backwards. So 1, 2, 3, true, Chris, 1, 7, 3. See how cool this is? I didn't have to use a loop to do any of this stuff. These were like all the drills that we spent so much time on in 173. But here it's just like boom, and you have it. And if you want to just simply reverse a list, well, you could leave this out, and it's assumed that you're starting at the end. So that's an easy way to reverse a list. Okay, so that's slicing in a nutshell. So now I just want to quickly mention strings behave exactly like lists, except they're immutable. So unlike a list where I can add things to the end of it with append, I could say x.append, or sinus, and I was able to add something. I can also remove things very easily by saying pop. Okay, so it tells me what I removed, and now notice it's not there anymore. Strings are like arrays, but you can't do that. So let's say s is equal to hello world, and so I can do the same kind of indexing. I say s at index 0. That's a capital H, which hang on a second. Print. Whoops, sorry. I meant to say s at index 0. There we go, capital H. Same thing, s at index -1. Well, that's a lowercase d. And I can slice strings too. I can say s from index 0 to 4. Whoops, not so nice. Maybe 0 to 5. Hello, there we go. And I can also concatenate strings. So I can say s is equal to s plus maybe a space plus s. So now it says hello world, hello world. Actually, if I want to go really crazy, let's just put a space on the end of this. Python has the shorthand. If I say s times 4, that will actually concatenate the string to itself 4 times. So this is interesting. And then, I can do the same kind of stuff. So I say s equal to s times 4. I can then slice it in reverse and do that. So basically all the stuff that applies to lists applies to strings. You just can't change the string unless you do an assignment like this with concatenation. Okay. So that's it. So I'm going to have you do a quick little exercise on slicing, and then we'll move on to one more thing.